So this is the Spring 18 practice midterm problem number 5. We're told the element gallium, Z equals 31. This is a fancy way of saying the nuclear charge is 31, meaning it has 31 protons in the nucleus, so that you can find the element on the periodic table. So this is just the 31st element listed on the chart. Has two natural occurring isotopes, gallium-69 and gallium-71, which have masses indicated in the problem. What is the percent abundance of the lighter of the two isotopes? Okay, so what we want to do on this problem, the main idea we're using here is that the average atomic weight for an element is equal to the fraction of all of its isotopes added together. The fractions times the atomic weight of each isotope, and we're summing all of these up. So some elements only have two. This makes it convenient to solve these types of word problems. So we could write that we have the fraction of the lighter isotope times the atomic weight of the isotope, which is 68.9257 AMU. I'll leave the AMU off the problem, plus the fraction of the higher or the heavier isotope times its atomic weight, which is 70.9249, and that'll equal the average atomic weight of gallium, and we can get that from the periodic table. So I need to check a periodic table. So the key here is that this we get from the periodic table. So it's 69.723 is what I read from the periodic table. Okay, now just a simple inspection of where this is relative to the two fractions might actually help me narrow in on my choices. So when I look at my choices, 68.9, 70.9, 69.7. So we are closer to the lighter isotope. So it seems as if the answer is probably going to have to be A, just from simple inspection, okay? Because if it's really 97% of the lighter isotope, then the atomic weight's going to be much closer to 68.9257 than what it actually is. If it's actually about 50-50, then it's going to be a bit closer to 69.9 to being right about in the middle. And if it's really 39%, that actually is probably just the fraction of the heavier isotope in this problem. In fact, if you add A and B together, that's what you would actually get. So if we mix up what we think the fraction of the lighter and the heavier are, then we might arrive at answer B. Okay, now, if you actually want to solve for this, if you want to solve for this algebraically, the main idea in this problem is since there's only two possible isotopes, then the fraction of the lighter isotope plus the fraction of the heavier isotope must equal 1. Or the percent of the light plus the percent of the heavy must equal 100%. Since there's only two. So that's what we get from the only being two natural occurring isotopes. And so that might allow us to write that the fraction of the lighter isotope times 68.9257 plus the fraction of the heavier isotope would be 1 minus the fraction of the lighter. So we can write the fraction of the heavier isotope would be 1 minus the fraction of the lighter. And then have that times 70 point and set that equal to the average atomic weight from the periodic table, 69.723. Okay, so we should be able to just algebraically solve. It takes a little bit of effort to actually solve algebraically if you want to write it out to solve directly for the 60.119. But that's how you can solve for the number if you wish. You could also look at this problem a little bit differently. You can say, well, I could plug in 0.60119 here and then 1 minus that here and see if I get the right atomic weight. So you can think of a variety of ways to solve a multiple choice problem of this variety in an exam setting. This problem has a lot of different choices on how you might approach it. I hope I've given you a few here to help you better think about the problem.